Okay. Then Akshata Belvi.
Present, sir.
Akshata Belvi. Okay. Pooja Patil.
Present, sir.
Okay. Pooja Patil. What is your roll number, Pooja?
23, sir.
Okay. Okay, fine. Bhakti. Bhakti, roll number 10. Okay, right. Fine. So in the last class, uh, we stopped at the timer bar counter programming. Let us start with the serial communication. Okay, serial communication. Are you able to see the screen? Screen is visible?
Yes, sir.
Yes, sir.
Okay, fine. So module 4 is all about the serial communication and interrupt programming using assembly and C language. First of all, we have to know what is the meaning of communication. Okay, we talk with others, right? We communicate with others. Okay, now what is the meaning of actual communication? Communication means it is the exchange of meaningful information between the sender and the receiver, or between source and the destination. Whatever information we are conveying, that should be meaningful. Okay, if we are conveying anything, it is not understood to the other side, if it is not understandable to the other side, then it is not called as a communication. It's not a proper communication. Communication means exchanging of meaningful information between sender and the receiver. That is called as the communication. In communication, there are two types, as you are aware. One is serial communication, another one is the parallel communication. Correct? Serial communication and the parallel communication. Let us see few of the differences between serial and parallel communication, or the comparison between serial and parallel communication. So can you just think of what may be the differences between serial and parallel communication? Any idea? Serial and parallel communication, what may be the differences? Just the name itself will tell what is meant by serial communication and what is meant by parallel communication. Can you tell any of the differences? Serial communication, what will happen? Yes, please. In serial communication, what will happen? The data is transmitted bit by bit. Yes or no? The data is transmitted bit by bit, one after the another, in a serial fashion. Okay. In parallel communication, all the bits are transmitted, all the bits are received at the same time. All the bits are transmitted, or all the bits are received at the same time. That is parallel communication. Okay. This is the first difference. Then in the second one, in the serial communication, it requires only one line between sender and the receiver, or between the transmitter and the receiver. For parallel communication, it requires many lines to be drawn between the sender and the receiver, because there are many bits which are to be transmitted or received at the same time. Therefore, we require many lines to be drawn between sender and the receiver. Okay, this is the second difference. And third difference, which is faster? Serial communication is faster or parallel communication is faster? Yes. Whether serial communication is faster or parallel communication is faster? Which is faster? Yes, please. Which one is faster? Akshata? Belvi?
Serial, sir.
Serial is faster or parallel is faster? Which one is faster?
Serial only, sir.
Serial is faster. How? How serial is faster? Can you justify?
It is
Pooja?
direct by bit, no, sir.
Yes, please. It is directed by,
Bit by bit, it will transfer, no, sir.
but here in parallel, all the bits are transmitted at the same time at a stretch. So which is faster?
Parallel, sir.
Parallel is faster, is it not? Because in parallel, all the bits, suppose say there are 8 bits. In serial communication, what is happening? First, the LSB is transmitted, then the next bit, then third bit, Like this, it will go on transmitting up till MSB bit, 8th bit. Okay. In parallel communication, what will happen? All the 8 bits are transmitted or all the 8 bits are received at the same time. Correct. So parallel communication is faster than the serial communication. Okay. This is the third difference. Next. Now, in serial communication, it requires only one line to be drawn between sender and the receiver. So it is cabling cost is less and hence it is cheaper. In parallel communication, many lines are drawn between the sender and the receiver depending on the number of bits and hence it is costlier. Parallel communication is costlier. Which is reliable then? Serial communication is reliable because it requires only one line to be drawn between sender and the receiver. Cabling cost is less, it is cheaper, and hence serial communication is more reliable than the parallel communication. Okay. Then example for serial communication is data transfer in LAN, local area network, between two systems using RS-232 cable. Between two systems, between two PCs, the LAN cable or the RS-232 cable is connected in a local area network in a LAN communication. That is nothing but the serial communication example. And the example for parallel communication is the communication between the PC and the printer. Okay, communication between the CPU and the printer using a cable. That cable which is connecting the CPU or the computer and the printer is called as a GPIB cable. It is general purpose interfacing bus cable, GPIB cable, general purpose interfacing bus cable. Okay, this is the example of the parallel communication. Fine. Now, little bit basics of serial communication. Classification of communication is of two types based on how the transmission occurs. The first one is based on how the transmission occurs. The transmission can be of three types. One is simplex, second half duplex, and third one full duplex. Right? Which are the different ways of communicating. Okay. The first type of classification is based on how the transmission is taking place. That is simplex, half duplex, and full duplex, three types. In simplex type of communication, data transfer takes place only in one direction. Data transfer takes place only in one direction in simplex communication. Okay. Example of this is data transmission between computer and the printer. It is only one way, is it not? Can we transmit the data from printer to PC? No. It is only from the PC or the computer to the printer, data communication. This is the example of simplex communication. The next is half duplex. In half duplex communication, the communication is taking place in both the directions, that is from sender to receiver and from receiver to sender, but not simultaneously. The communication is in both ways, but not simultaneously. This is called as half duplex. The umpires on the cricket ground, the walkie-talkies they use. Okay, umpires on the cricket ground using walkie-talkies. Okay, right. That is the example of the half duplex. Right, umpire can speak to the other end, but it is not two-way, and the receiver can also speak to the umpire, but it is not one-way. Okay, this is example of the half duplex. Then the full duplex. Full duplex communication is there can be communication in two ways and also simultaneously. For example, the communication on the telephone lines, transmission through telephone lines, okay, telephonic conversation. That is two-way communication and it is also simultaneous. Both sender and receiver can speak at the same time. Okay, that is full duplex communication. That is what I have illustrated in these diagrams. That is, first one is the example of simplex communication where there is a transmission from terminal A to terminal B. It is only in one direction communication. Then second type of communication is half duplex. That is, sender can send to the receiver and receiver can also send to the sender the data, but it is not simultaneous. It is not simultaneous. The third time is the full duplex. The sender can send to the receiver and the receiver can also send to the sender and it is simultaneous. Okay, transmission in both directions are simultaneously taking place in full duplex communication. Okay, simplex, half duplex, and full duplex communications. The serial communication consists of transmission of bits of data through only one communication line. In serial communication, the transmission of data is through only single communication line. Okay, the data transferred bit by bit in two ways. Okay, that data transmission takes place bit by bit, one bit after another bit in two ways. One is called as synchronous communication, another one is called as asynchronous communication. Okay, first classification is based on how the transmission occurs, that is simplex, half duplex, and full duplex. The second type is based on the data transferred, that is synchronous, whether all the data bits are that is the whether the clock signal is used simultaneously between the sender and the receiver, and two separate clocks are used between the sender and the receiver. Based on that, there are two types of classification. One is synchronous communication, another one is the asynchronous communication. In the synchronous format, what is happening is transmitter and receiver are applied with the common clock signal. There is a single clock signal applied to the transmitter and the receiver, common clock signal. That is why it is called as synchronous communication. Clock signal are connected to transmitter and receiver is only a single clock, and this synchronous communication is used for block transfer of data. Okay, set of data are transmitted, whereas in asynchronous format different clocks are used for transmitter and receiver. There is a separate clock for transmitter and a separate clock for the receiver, and this asynchronous format is used for character oriented data transfer, that is bit by bit data transfer takes place, or character oriented data transfer takes place in the asynchronous format. Okay, synchronous and asynchronous. Are you following here, students? Mantesh?
Yes, sir.
Mantesh, you are following? Okay,
Yes, sir.
okay, fine. This is the figure which is showing the synchronous format. In the synchronous format, as I told, there is a common clock signal applied between the transmitter and the receiver. There is a single clock between the transmitter and the receiver, and there is a data frame. This is called as a data frame. That is a set of data bits which are to be transmitted from the transmitter to the receiver. It is called as a data frame, and this process is called as data framing. Okay, the set of data bits which are to be sent from the sender to the receiver or from the transmitter to the receiver, it is called the data frame, and the process is called as the data framing. Data framing. Okay, now here in synchronous format, it is block oriented of data. It's a block of data or the set of data which is transmitted between sender and the receiver, and here it requires synchronous bits to be added for the synchronization between the transmitter and the receiver. Okay, for the data to be transmitted from sender to the receiver, synchronization bits are to be inserted in between the data bits. So this what you are seeing are the data bits here, right? And at the beginning the synchronous bits are added. So similarly, after sending the first set of data, other synchronous bits may be required to be added, and then the data whatever is to be sent, that is sent from the transmitter to the receiver. Okay, so this is how the data transmission takes place in the synchronous type of communication. Okay, then what about in the asynchronous format? In the asynchronous type of communication between the sender and the receiver, this is how the data bits are arranged. This is how the data bits are arranged, and what you are seeing at the beginning is the stop bit. Stop bit is always 1, and the start bit is always considered as 0. Okay, so stop bit is indicated by a high or a 1, and the start bit is indicated by a 0. So whenever this start bit arrives, then the data whatever is to be transmitted, that is sent out from the sender to the receiver. Okay, so once a stop bit arrives, then what will happen? Whatever data is sent, that is indicated that after sending the data, if there is a stop bit, it indicates that the data transmission should stop, or the data transmission has occurred. Okay, so this is how the start bit and the stop bits are used to indicate the start of transmission and the stop of the data transmission. These are the data bits or the byte of data, what you are seeing here in blue color mark. Okay, in between these is what you are seeing are the idle bits or the mark bits. Okay, so these idle bits are inserted in between the start bit and the stop bit, in between the start bit and the stop bit, which indicates that there is no data which is communicated from sender to receiver. Okay, if there is no data between sender and the receiver communicated, then there is a idle bits which are inserted, or they are also called as mark bits which are inserted, and that is nothing but the high level or the bit data 1. Okay, bit 1 being inserted in between if there is no data transmission occurring. Okay, those are called as the mark bits or the idle bits. Also you can see at the end here, after the start bit there is no data transmission, so idle bits or the mark bits are inserted. Okay, that is bit 1. Fine. So this is how the asynchronous format takes place, and The sender is connected by a different clock and the receiver is connected by a different clock. There are two clock signals which are applied separately. One clock signal for the sender, another clock signal for the is applied to the receiver. And hence it is called as the asynchronous format. Fine. Let us now compare synchronous and asynchronous type of communication. In the synchronous type of serial communication, transmitter and receiver are connected by a common clock. First difference, right? And in the asynchronous communication, transmitter and receiver are applied with the separate clocks. Fine. And in synchronous communication, data transfer takes place in blocks. And in asynchronous communication, data transfer is character oriented, or it is depending on the bits, the start bit and the stop bit and the idle bits. That will decide the data transfer in the asynchronous serial communication. Whereas in the synchronous serial communication, there are synchronization bits which are added or inserted during the data transfer. And in the asynchronous communication, start bit, stop bit, and the idle bits are inserted wherever necessary to proceed with the data transmission between the sender and the receiver. Synchronous serial communication, it is preferred for high speed data transmission. Why there is high speed data transmission in synchronous and why not in asynchronous? Any answer from your end? Synchronous communication, there is high speed of communication or data transmission. In asynchronous communication, the data speed transmission is less. Why it is so? Yes, anybody?
So with separate clocks is applied in asynchronous.
Exactly. Yes, exactly. In synchronous serial communication, there is a common clock signal in the sender and the receiver, and hence it is faster. Whereas in asynchronous communication, there are two separate clocks, and hence the speed will decrease in the asynchronous communication. Clear here? These are the differences between synchronous and asynchronous serial communications. It is serial communication, remember, synchronous serial communication and asynchronous serial communication. Now, in the 8051, if there has to be serial communication, the serial communication will occur using the TXT and RXT pins of the microcontroller. There are two pins, TXT pin, that is transmit data pin, pin number 11. It is also P3.1 pin. It is having dual functions. Port 3 pins, we know that they are having dual functions. Is it not? The port 3 pins of the microcontroller, they are having more than one function. That is, they are having dual functions, two functions. Then receive pin, receive data pin number 10 is also pin number P3.0. So these two pins, TXT transmit data and RXT receive data, are the two pins which are used for the serial communication using 8051 microcontroller chip. Then the frequency of communication. At what frequency the data bits are transmitted? It is called as the baud rate, right? What is the baud rate? How many bits are transmitted per second or how many bits are received per second. The frequency of the bits transmission or the frequency of bits receiving. This is called as the baud rate in serial communication. What is the baud rate? It is the rate at which, or it is the frequency at which the bits are transmitted or received. This is called as the baud rate of the serial communication. Okay. Now this frequency of operation, that is the baud rate, is decided by two factors. One is it can depend on the crystal oscillator. It is decided by the crystal oscillator. The crystal oscillator will fix the baud rate. That baud rate should be this much depending on the crystal frequency. Okay, external frequency or the crystal frequency. Then another type of baud rate that is possible is it is based on the timers that we are using. The timers, we have seen the different modes of the timers, is it not? Timer mode 0, mode 1, mode 2, mode 3. So based on these timers and the timer modes, we can fix the crystal frequency or we can fix the baud rate of the serial communication. Okay, so these are the two types of the that is baud rate transmission that can occur with the serial communication, right? Then this serial communication is achieved by two registers. One is the SBUF register, another one is the SCON register. SBUF and SCON registers are used for the serial communication. Just a minute, just hold on. We just come back here. This is the what is called as the structure of the SBUF register or the serial port buffer register. Okay, structure of the SBUF register or the serial port buffer register. SBUF register full form is serial port buffer register. Are you able to hear, students? Students,
Yes, sir.
are you able
Yes, sir.
to see the video and audio?
Yes,
Yes,
sir.
Mantesh? Okay, fine. So SBUF register is the full form of SBUF register is serial port buffer register, and the expansion of SCON register is serial port control register. Okay, these two registers are involved in the serial communication of the 8051 microcontroller. Okay, now we'll see the structure of the SBUF register. Sometimes in examination they are asking the structure of the SBUF register or the serial port buffer register. Okay, now this SBUF register is physically two registers. What it means is whatever data is to be transmitted out of the microcontroller through serial communication, that is stored in SBUF register first, and then through TXD pin, transmit data pin, it is transmitted out of the microcontroller. Okay, with the required baud rate or with the required clock applied. Okay, what is the point here? The point is SBUF register, it is physically two registers. The meaning of physically two registers is whatever data is to be transmitted out of the microcontroller, that is stored in SBUF register first, and through the TXD pin, transmit data pin, it is transmitted out of the microcontroller. Okay, that is SBUF for transmitting the data out. Okay, now whatever the data is to be received inside, right, that data is to be received first in the SBUF and then it is transmitted wherever it is required inside the microcontroller. But while the receiving of the data through RxT pin, the data is received into the shift register first, which is having the required baud rate, okay, for the receiving of the data, and then whatever data is received by the shift register, that is converted from the serial to parallel conversion. There is a serial to parallel out shift register which will convert the serial data input into parallel output, and that parallel data is stored in the SBUF register. Parallel data is stored in the SBUF register. From SBUF register, once it is stored, then that can be read. It can be only be read, it cannot be written. Okay, into whatever registers we want, we can read that data wherever we want. Okay, so this data whatever we want to transmit, that is stored in the SBUF register, it is write only and then transmitted out through TXD pin, and whatever data is to be received, right, that is received by the shift register first. It is converted from serial parallel conversion using SIPO register or using serial in parallel shift register, and the parallel data is stored in the SBUF register. From this SBUF register, it can be read in any other part of the microcontroller or any other block of the microcontroller. Okay, so this is how the SBUF register structure is all about. This is called as the structure of the SBUF register or the structure of the serial port or the structure of the serial port buffer register. Okay, so in examination, if the question is explain the structure of the SBUF register or explain the structure of the serial port, then you have to draw this diagram and you have to explain. Clear here? Okay. So in today's class, students, we discussed about the serial communication basics, right? What is communication? It is a means of exchanging meaningful information between source and the receiver. There are two types of serial communication, serial communication and the parallel communication. Serial communication, we saw the differences between serial communication and the parallel communication, a comparison between serial communication and parallel communication, right? Then the different types of classifications of serial communication: simplex, where the data transfer is only one direction; half duplex, data transfer in two directions but not simultaneous; full duplex, where the data transfer is simultaneous and in both the directions. Okay, so this is the diagram which shows the simplex, half duplex and full duplex communications. Then one more type of classification is based on the clock signal that is applied to the sender and the receiver. If a common clock signal is applied to sender and the receiver, it is called a synchronous communication. If two separate clock signals are applied to the sender and receiver, it is asynchronous communication. This is a diagram which shows the synchronous format or the synchronous communication between sender and the receiver using the synchronization bits. And in synchronous communication, it is block oriented, right? And in asynchronous communication, data are transferred character by character or it is bit by bit. And here in asynchronous communication, we are using start bit to start the data transmission, stop bit to indicate stop of the data transmission. If there is no data transmission in between, then that is indicated by the mark bits or the idle bits. Okay. Between the two, that is synchronous communication and asynchronous serial communications. Then later we saw how the serial port of the 8051 microcontroller is accessed, that is through the TXT pin and RXT pins of the microcontroller. The frequency, that is the baud rate, that is the frequency at which the data bits are transmitted or received per second, is nothing but the baud rate. And this baud rate is fixed, one by the chip oscillator or the crystal oscillator, and the second way of fixing the baud rate is by using the timers. Timers in one of the microcontrollers are used to fix the baud rate. These are the two ways of setting the baud rate. Then there are two special registers called as special serial port buffer register and the serial port control register SCON, which are the two registers used for serial communication. Then later we saw the structure of the SBUF register or the structure of the serial port of 8051 microcontroller. Okay. Any questions here, students? On today's class, any questions?
No, sir.
Yes. Understood? Sure.
Yes, sir.
Akshata?
Yes, sir. Understood, sir.
Understood. Pooja? Pooja?
Yes, sir. Understood.
Any questions,
Yes.
Pooja?
No, sir.
Any problem in understanding?
No, sir.
Okay. Bharti? Bharti? Shafia? Okay, fine. Mantesh, any doubts here?
No,
Mantesh?
sir.
Any questions?
No, sir.
Okay, fine. Then we'll continue in the next class. Okay. Thank you.